Okay, this may not look like a CAD video, but it actually is. We're going to do this on a regular and recurrent basis to get you out of thinking of the fact that CAD or graphics is just what's on the computer. And we're going to do that, hopefully, getting you to review some things that I think you know. And so in this case, we're going to be looking at problem 4-3. Which is one of the set, and I'm going to kind of sketch it out here. It goes from A to B to C to D to E to F to G and back to A. It's kind of a rough sketch and I don't have a straight edge, but I'm going to give these A, B, C, D, E, F, and G. And there's a bunch of data given up here in terms of distances and a bunch of angles given here. There's an angle there of 85. And there's an angle here of 58. And there's really one true angle given, and that is this 37 degrees right here. All right, so what we're going to look at is the concept of back azimuth or reverse direction, back azimuth. All right, and we're going to do that for the reason that if you're given directions and then directions off of directions, eventually you can write something or sketch or use tools to use the polar commands, which would be the commands that say something like at. So that first one would be at a distance of 2.85 if you're going from A to B, and then use the less than symbol. And now you have to realize that 37 degrees is not its actual direction. Its actual direction is always off of this kind of standard position angle. And so your direction is 180 minus 37, or 180 minus 30 is 150, 143. All right, so that's how you could draw this first line. You would just say line, and then give it a point, something like 0, 0 if you're starting from 0, and then at. Now, what we're learning to do and what we've done in the last video and we'll continue to do is the fact that after you draw the first line here, what you do is you use that kind of snap. You grab the grips, you left select it, then you left select a point, and then you spacebar until you get to the copy command. Until you get the rotate command. You hit C for copy and you turn it 85 degrees. However, there is another more elegant way for those of you who, and all of you should be kind of at least aware of how we add up angles and how we use back azimuths in case you have to dead reckon sometime in the woods when your GPS does not work. And so here's what we know. We know that if this direction here is 143, then we know the opposite direction is 143 plus or minus 180 degrees. Either one. But the case would be usually you want to keep when you're thinking about it, you're thinking about keeping things from 0 to 360. And so if this direction is 143, then the opposite direction is 143 plus 180. So that's 3, and that's 12, and that's 323. So the opposite of 143 is 323, and that makes sense. And then why do we want to know that? Well, we're going to take the 323 and we're going to add 85 degrees to it, right, to get that new direction. So if we take 323, I'll just move the 85 over here, and we add 85 degrees to it, we get 8, and then we get 10, and we get 408, which in fact is a direction. It is 48 degrees more than 360, so that is 48 degrees. And so our next statement here could be at, and our distance that's given there for BC is 3.09, angle 48. And looking at that, that's a little steeper as shown on the drawing than 48, than 45, so that's probably about right. And now what do you do with the 48? Well, 48 is if you're running to C, but if you're running back from C to B or the back azimuth, it is 48 plus 180, which is 8, 12, 228. And so if you want to get the direction of CD, the direction of CD is 228 plus, because you're adding angles that are counterclockwise, is positive, plus 58, and you get 16 and 8 and 286. And that looks about right, so the next statement would be at 1.93 angle 286. And you could, as we've talked about before, you could line all those up in a script file and have the whole exterior done. Especially if you use something like Excel or just a calculator. But realize that there is a lot of this kind of mathematics, especially when it comes into balancing these angles. If you go through in each of these angles, if they don't all add up to the number of sides minus 2 times 180, then you know you did something wrong, and there's some implicit error in there, and you'll get into that when you get into tolerancing and the like for closing up angles. So I just wanted to point out the back azimuth. I wanted to go through this in about 7 minutes. If you know the back azimuth and you know it by another name, it is the reverse direction. So if you are going in a direction of 45, the reverse of 45 is 225. And a lot of times we know these. The reverse of 135 is 315, etc., etc., etc. So once again, remember that in AutoCAD, if you go at number, comma, number, it is a change in Cartesian coordinates. If you say at number less than symbol number, it is distance and direction. And each of these can be taken into 3D, by using a comma for a Z or a theta or an angle here for an elevation angle. All right, we'll post that one, and then I'll actually also draft this one up, show you the script file, and draft this one up using what you're going to be doing when you get these visual clues. But you want to really get used to adding and subtracting angles, and in fact knowing how to get a back azimuth calculated. It's relatively easy when you have degrees. When you get minutes, degrees, seconds, it's a little bit tougher, but it's not something that you should shy away from, especially if you start learning how to use Excel and something like that. That really is something that goes along with a drafting engine. Thanks for listening.